All right, in this video, we are going to talk about correlations, which are testing the relationship between variables. So for this chapter, we have several objectives. Now we're actually covering technically two chapters in one with this module, again, kind of like we did with t-tests. So we've got a lot of objectives. So we're going to describe what correlations are and how they work. That's going to be the bulk of this lecture. We're going to do a simple correlation with the data analysis tool. I've got a separate video for that. We're going to describe how to interpret the value of the correlation coefficient. We'll talk about that in this video. We're going to talk about how to test the significance of the correlation coefficient. And I'll talk about that a little bit in this video, but then I'll also show you how to do it in a separate video. And then how to write the results in APA format, which is also going to be a separate video. So lots of videos to watch this week. So let's talk about correlations. Now in the past couple of modules, we've talked about t-tests and ANOVA, so this is totally different than those two. But we still have some abbreviations. Remember with t-tests, we said T for two, T for t-test. ANOVAs, we called an f-test because they're so much fun, so those are an f-test. Now correlations are abbreviated with an R because we're looking at the relationship between two things. And I've noted here that the R is between variable X and variable Y. So you have two variables that you are looking at the relationship between them. It is possible to do more than two variables. I'll show you that a little later in this video. But the focus is really just two. Okay, so it's called a bivariate correlation for two variables. And the most important thing about correlations is that the values are going to range from -1 to +1. So what that means is that the obtained value, so we looked at that t-stat, we looked at that f value, now we're looking at an r value, or a correlation coefficient, is going to be between -1 and +1. With t-tests and ANOVAs, the value that you get from those tests can be literally anything. It could be -37, it could be +82, but it could also be really little. It could be 0.16. But with correlations, we have this really, really narrow range from just -1 to +1. So correlations essentially look at how the value of one variable changes in relation to the to another variable. So we've got several different types of correlations, and we're going to talk about those over the next several slides. Okay. So the first type of correlation we have is called a positive correlation or a direct correlation. So the variables change in the same direction. So when one variable increases, the other also increases. Now a classic example of this is, let's say temperature, that's variable X, and ice cream sold, that can be variable Y. So this is a positive correlation or a direct correlation. Don't think of positive correlations as being quote-unquote good. Think of positive meaning they both move in the same direction. So you might want to use the word direct to help keep that clear in your notes or as you study. So anyway, as variable X is temperature, variable Y is ice cream sold. So think about as the temperature gets hotter, as temperature goes up, the number of ice cream sundaes, let's say at Andy's, sold also increases. So that is a positive correlation. Now on the other side of that, we have a negative correlation. Now don't think negative correlations are quote-unquote bad. It just means that the variables move in opposite directions. So I've noted here that it could also be called an indirect correlation. So this is when the variables move in opposite directions. When one variable increases, the other variable decreases. So as an example, one that I'll work with later is as amount of minutes spent exercising increases, weight may decrease. Okay, so as someone is trying to lose weight, we see a negative correlation between exercise and weight. Okay, not a bad thing, it's just that is how the two variables are related to each other. Okay, so some highlights to remember. This is the most important one. -1 to +1 is your value range for a correlation coefficient. So this is what Excel will kick out whenever you do your calculations, okay? Now, the absolute value indicates the strength of the correlation. So a -0.8 is the same strength as a +0.8 correlation. Okay, same thing with like a -0.16 it's the same value as a positive 0.16, so it's the absolute value. And as I noted, you may want to use the phrases indirect and direct instead of positive or negative to keep from thinking about quote-unquote good and bad as the relationships. Okay, and just remember, our correlation coefficient is the small letter R for relationship. Okay? So whenever we, kind of taking a couple steps back, we talked about charts and graphs a couple of modules ago. So let's revisit them because we have a very special kind of graph that can display correlations. It's called a scatter plot. So the general shape of the scatter plot can tell you if it's a positive or a negative correlation. So this is just a real simple scatter plot. We can see variable x is here, variable y is here. So one variable is on the vertical, one is on the horizontal. So if I did a perfect positive correlation, this is a 1.0 correlation, we'll see that the dots are all in a perfect little line, okay? And so this is pretty rare to see, but this is illustrating as variable x goes up, variable y also goes up. Go up to 3, up to 3. So as there's an increase in one, there's an increase in the other. So this is a positive correlation. If you have your dots going this way on the graph, that means it's a positive correlation. So what you might see is something more like this, where we have maybe somebody hanging out over here, but generally the dots are going this way. So if I draw a line with the scatter plot, and you may remember that from your previous math class called the line of best fit, where you try to hit as many dots as possible, you'll see that this is also a positive correlation. But a negative correlation looks very, very different. A negative correlation actually goes the opposite direction. So as one goes up, the other variable goes down. So this is the direction that a scatter plot will display a negative correlation as. Okay? So another way to kind of visualize what we're working with when we have correlations. Now, as I mentioned earlier, we're working specifically with two variables when we do correlations, but you can examine more than two variables at one time using what's called a correlation matrix. And I will show you how to create this in the video where we work in Excel. But this is what Excel will give you whenever you create it. So I have four variables here: income, education, attitude, and vote. And I want to see all of the relationships between all these variables at one time, and that is what the correlation matrix does. So if I look at income, I can see the relationship between income and education is 0.57, roughly. And I can see the correlation between income and attitude is negative 0.08, and the relationship between income and vote is negative 0.29. So I can see multiple relationships on this correlation matrix all at one time. So you don't have to do each individual pair as you go, okay? Now, keeping that in mind, we're going to work with this income column. These values, you know, this one is a positive correlation, right? Income and education. Why is it positive? Because it's a positive number. So as education increases, income also increases, okay? Attitude and vote are both negative correlations. Why are they negative correlations? Because they're negative numbers. So we know the direction, but we also need to know strength. So this is kind of a rough guide for how to determine the strength of a correlation. Now remember, the absolute value determines the strength. So just because it's a negative 0.08 does not mean that it's weaker than a positive 0.08. So here's my categories: weak or no relationship, weak to moderate, moderate, moderate to strong, or strong. So that is what we will use for part of our APA format is part of this. You'll need the direction and you'll need the strength. Okay, I'm going to wrap that up, and then in the next video we will continue on, talk about something a little more abstract, as well as get into our steps to computing a correlation coefficient.